So, 2005 Form B, question 2. This is also an AP Stat question. Of course, we changed it up a bit. But it says, for an upcoming pet walk, each family may purchase up to 3 dog passes and 3 cat passes. Let D be the number of dog passes purchased by a single family. The probability distribution of the number of dog passes purchased by a single family is given in the table below. All right? So, first question says, compute the mean and standard deviation. Well, I immediately saw answers with no work, and that really made me sad. But I'm sure what people did is they went to their calculator and they put the information into stat edit, and they had the X's in L1, the frequencies in L2, and they went stat calc, one variable statistics, second one, and then they made sure their freq was on, and they went second 2. And they go, all right, there's my average, there's my standard deviation. They wrote down 1, I call it good. And I'm just going to tell you right now, Mrs. Lamb will tell you that's bad. You got no points. And we're sad about that. And I know you are too. So the expected value, here's the formula. And by the way, you will have access to a formula chart on every single test. I'll remind you where it is, but it's on my website. But the expected value, or the mean of X, equals the individual X's times the probability. All right? So the work shown would look something like this. My X's, which are D's in this case, 0 times the probability, plus 1 times its individual probability, plus 2 times its individual probability, plus 3 times its individual probability. That would be my work shown. And obviously I did the work on a calculator because I wanted to eliminate the errors, but I have to show the work. So on average, we expect a customer to purchase 1 dog pass. That's what we expect. The standard deviation, all right? Well, that's my individual X's minus the average, which we just calculated. All right, we just calculated that average is 1 times the individual probability. So this is my work. So my individual X minus the mean times its associated probability. My individual X minus the mean times its associated probability, etc., all the way across to the individual X minus its probability, minus the mean times its probability, and we end up getting 1 dog pass. All right? So suppose that was for dogs. Suppose the mean and standard deviation of the number of cat passes purchased by a single family are 2 and 1.2. So they're telling me this is my mean, this is my standard deviation. Assume that the number of dog passes and cat passes are independent random variables. I'm going to talk about this for just a second in a moment. Compute the mean and standard deviation of the total number of dog and cat passes purchased by a single family. So here we have 2. Here I have 2 random variables, and we're going to combine them. Well, that's not a problem with means or medians. We can combine them under any circumstances, and we get to follow the normal rules of mathematics. So we just add them. So here's my cats plus my dog equals 3. On average, we expect the family will purchase 3 passes for the dogs and cats. But when we get to standard deviation, we have several things that are going on that are a little bit different. First off, to combine standard deviations, we can't combine them unless they tell us the variables are independent. If they're not independent, we do not have the ability or the knowledge in this course in order to combine them. So in this case, unless they tell us they're independent, we can't combine the standard deviation, which would be great. You could just sit there and go, not independent, don't have to do the work. Or actually, you couldn't say that. You'd have to say not independent, therefore we can't combine standard deviations. But they told us they're independent, so now we have to do that. All right? So in order to do that, I have to convert them back to a variance. So there's my dogs, my dog standard deviation of 1. Here's my cat standard deviation of 1.2. I convert it to a variance, both of them. I add them together, then I take the square root of them, and I get 1.562 passes. All right? So each family, this would be the standard deviation for the number of passes they purchased. So that was combining the random variables. Now we're going to make it a little more complex. Suppose each dog pass costs $15 and each cat pass costs $25. Compute the mean and standard deviation of the total amount spent per purchase. All right? So they want to know, what am I going to spend per purchase? It's like, oh, well, that's not too bad. Because for mean, it's like, well, I expect him to buy one dog pass. Excuse me, I should slide that up. I expect him to get one dog pass, and I expect him to get 2 cat passes. All right? So one dog pass, one cat pass. So 1 times 15, one dog pass times its price of $15, plus 2 cat passes times its price of $25. So on average, we expect the family will spend $65 on their dog and cat purchases. When we go to actually put together the standard deviations, well, a couple things I want to remind you. First off, we can't add a constant to standard deviation, but they're not asking me to add a constant. They're asking me to multiply by a constant, and I can do that. All right? And there's 2 different ways to do that. I'm going to look at the one below more specifically. And basically, I went 15 times 1 gives me a new standard deviation of $15. And 25 times 1.2 gives me another standard deviation of 30.5. So my cat standard deviation is 30.5. My dog is 15. And I want to combine them. We already know that they're independent. Because they're independent, we can combine them. And so I have to convert them to a variance. So 15 squared for the dogs plus 30 squared for the cats, added together and take the root of it, gives me $33.54. That's the way I like to approach this problem in my head. Okay? However, I do want to remind you, the reason I showed this, because this is likely to show up on a test at some point in your life, that when you're working with variance, you have to square the constant. So there's a variance because it's squared, and there's my constant where I had to square it. All right? But either method, either one of these 2 methods, is a full credit response, but you must show your work one way or the other. All right. The last thing says compute the median. I highlighted this in yellow. The reason I highlighted it in yellow is because this wasn't an AP question. All right. And some of you said, Mr. Spencer, you didn't show us how to do this. And I'm going to say, well, you know, it's 50%. Right. So when I look at this, I go back to the table, and my table says, oh, that's only 40%. That's not enough. But when I go up to 1, I've crested over. So the very first one I crest over is where my crest over 50% is where my median occurred. Did you have to make a list of this like this? No. This is just what I did as my cumulative. I was at 40%, and now I crest over because the 40 plus the 30 made it 70, and this is where I crested over 50%. So the median is 50%. And I will let you know that because this is not an AP question, there will be a fair amount of leeway as long as some explanation is there when Mrs. Lamb and I go to grade that. All right? I'm going to go ahead and switch that over to Mrs. Lamb.
Mr. Spencer, on that last question of median, how do you feel about if they say the number of tickets is somewhere between 0 and 1?
You know what? I would probably let that slide this time around, but for discrete probabilities, if that comes up on an AP, and here's why I growled. I growled because I want to be reasonable with you guys, and so I think being reasonable is to let it slide this past. But on the AP, if we were dealing with discrete probabilities, the median is not going to be between 0 and 1. It's going to be 1. And we've done and we did do graphical problems earlier this year where the median, on an assignment where the median had to be a whole number like that. But here I think we're going to be flexible on this, but please know that for a discrete probability, it would need to be 1. So someone asked, and I have not paused the recording, but I am going to pause the recording.
We are now talking about scenario 2 PDF. So here's your official College Board scoring guideline for this problem. I do want to reiterate, right? Like when we talk about the College Board grading and what's credit, what's not credit, is different than what we do on the quizzes. Quizzes, we're doing a point scale. So in general, quizzes, you are awarded more points because we're doing more partial type credits than on College Board. So I hope you guys are not like freaking out going, oh my God, I got 0 credit on everything, right? Because on the quizzes, we are looking for, it's a different criteria. So please, let's not freak out. We just want to share with you on the actual AP exam, what would constitute, we need to start getting in that mindset and training you guys so that, each time we take a quiz and each time we take a test throughout the year, we're getting closer and closer to matching what College Board is looking for work. So please, let's not all freak out about everything.
But on the tests, we do grade by College Board.
Yes, we do. So these are quiz questions. So they're a point scale. So you can earn more partial credit than what's here listed on the official scoring guideline. Okay, the big takeaway for scenario 2 is no work, no credit. In the scoring guidelines, it iterates that a lot. You do have to label your work. This is my work for the mean. So you'll notice on their rubric, they didn't use a symbol for the mean. They just said the mean. In the standard deviation, they didn't use symbols for that. But you do have to show the calculated work equation like we did in our notes in our journal. We showed you how to write out what the work looks like, but then let the calculator do the calculating part for you. So so that has to be there. And then they made a special note down here, unsupported answers will be scored as incorrect. So again, you have to justify your work. If you missed the mean but got the standard deviation, that would be a partial for that. So they do recognize that you can get partial for part A or a partial for part B, and things like that. There was one more thing I wanted to talk to you guys about. No, that's for the next one. What does the work look like? Sometimes it's just adding the numbers, right? Your average. So as long as you're just showing, even if you think it's, oh, I'm just adding 2 numbers, write it down anyway. I know that you guys can do it in your head, but when we ask for work to be shown and you're just adding 2 numbers, write it down anyway. All right. Is there any questions about how College Board would be scoring this question?